Hey, what's up, guys? How's it going? In this video, I want to go through this LeetCode problem number 57, insert interval. So this question was asked by, let's take a look at the company, by Google and Apple, Amazon, and also Twitter and Uber. So this is one of the very fairly popular questions. Let's take a look at it. So we are given a set of non-overlapping intervals, and we need to insert a new interval into this given intervals, and then find the right spot to insert it. And we need to do some merging if necessary. Also, we can assume that the given intervals list are sorted according to their starting time. So let's take a look at some examples in here. The intervals is this 1, 3, and 6, 9, and we have a new interval, and that is a 2 and 5. And the 2 and 5 will merge with the 1 and 3, and that the function will output this 1 and 5 and 6 and 9. The 1 and 3 and 2 and 5 being merged together. And for the second example, we have a list of these intervals, and the new interval that is to be inserted is 4 and 8, and the output will be 1 and 2 and 3 to 10. So all these 3, 5, 6, 7, 8, 10, and it will merge with the 4, 8, because the 4 and 8 is overlapping with these three, and then the last one will be just by itself. And for the third one is a very trivial case, which we are given a empty list, and we has no intervals in it. So and then we have a new interval which is 5 and 7. So pretty trivial. Just inserted that the new interval into this empty list. The fourth case is we have an interval of 1 and 5, and the new interval is 2 and 3, and then 2 and 3 is overlapping. Actually, 2 and 3 stays inside this 1 and 5. That's why we is outputting 1 and 5. And for the fifth example, this is the other way around. So sorry, this is not the other way around. This is a merging case. 1 and 5 merged with 2 and 7, and then we have a 1 trivial where we have a 1 interval which is 1 and 7, and which is the merge of these two components. Feel free to pause the video and then have a try. And I'm gonna present my solution in this Google Colab platform. So I will share the link in the description down below, just so you can take a look at it. So this is some walkthrough, and I have a template to walk through the cases that's possible. So the blue bars in here is indicating the intervals, the existing intervals, and the green bars is indicating existing intervals, and then the blue bars they are the new interval to be inserted. So in this case, number 1, and the blue bar stays on the left of all the existing intervals. So the new product will be just a very trivial case, just everything just insert it at the first spot in the list. And similarly, for the case where the new intervals is on the right of all the existing intervals. So, and we just simply insert these blue intervals at the end of all the existing intervals. So we can quickly incorporate these two cases by using this these three conditions. So if the first interval, the starting point of the first interval is even greater than the ending point of the new interval, so that's being this case over here. The starting point, the very first starting point, because all these intervals are sorted, so that's why the first one will be the smallest one, and that one is even greater than the ending point of the new interval, and we just insert it at the first spot. And another example is this one. If the ending point the endpoint of the endpoint of the last interval that is less than the starting point of the new interval, and this one will be the new interval can be appended at the end of the intervals. So have this one, and also we have another case where the intervals is an empty list, and we just simply just return a list of the have only one element, which is the new interval. So these all are three trivial case, just pretty easy to handle. And then we can take a look at these two cases, 3 and 4. So if the new interval is somewhere in between, and the end product looks like this, in a merging, there's some merging going on at the middle, and there's not much modification at the two ends. And a little bit slightly more complicated is we have another one in here, and the third case is fourth cases was pretty similar, and there's some merge going on. So some merging going on at the middle, and the left and the right just stay as they are. So what we can do is to have a for loop to loop through all the elements. So if the endpoint of the interval is less than the starting point of the new interval, and we just insert it at the beginning of the list. And if there is some overlapping, we need to do some merging. And then if the interval is on the right of all the merged, if the interval is on the right of the merged intervals, and we can append it at the end. So let's take a look at the code to see how can be implemented. And by the way, this is gonna be a big O of n. You just scan the intervals one time. That's why this algorithm is really efficient. And so I will go through this helper function later, and I just want to give you a general overview of what's going on. We loop through all the intervals, look at each one of the interval. If the interval is completely on the left of the new interval, and what we do, we have a return list which we will return at the end, which is you just push this interval to it at the beginning. So that is gonna take care of all these cases. It's on the left of the new interval, and we simply just append it. And then if the interval that we are looking at overlaps with the merge interval, and the merge interval at the beginning is just the new interval itself, it's just a copy of that. And when there is some overlapping between the interval and the merge interval, we will just simply merge it. And then that will become a new merge interval. So next one, so basically it is taking care of this case. So this one and the new interval has some overlapping, and they will merge together, becomes something like this. And the next one, when they come across this guy, which has some overlapping with it as well, and then the merge will be done again. So I think here is easy to see. So when we come across the interval that has some overlapping with the system one, it will merge together, become a longer bar, and then when it come across the next one, it will merge, which does nothing because it stay inside this one. stays with this inside of this merge interval, and then this merge interval meeting is coming across another one which has some overlapping again, and then the merging will be happening again until we see no more overlapping. So this is what this function is doing, this statement is doing. And then if we're coming across the case when the interval is on the right, with not much, the interval is on the right of the merge interval with no touching, with no overlapping, and what we do, we just append if that merge interval is not already in the return list, what we need to do is to append this merge interval to that return list, and then this return list need to, and then the interval need to be appended to the return list as well. And to avoid this merge interval being appended multiple times, that's why we need this if statement in here. And if this part is now being executed in the for loop, that means there is no interval, there's no interval on the right of the merge interval. If that's the case, we still need to append this merge interval to the return list. So this is basically the framework of the algorithm. And now let's take a look at the helper function. So it's pretty straightforward. The help function, the first one we look at is on the left, right? On left. So if this function is taking care of this case. So if the ending point is before the starting point of the new interval, that is indicating the interval. The existing interval is on the left, is completely on the left of the new interval. So this basically is comparing the endpoint to the beginning point of the new interval. And similarly, when the starting point is even greater than the endpoint of the new interval, and that means that interval is the existing interval is on the right with no touching and no overlapping of the new interval. So that's basically this case on the right. The existing interval, the starting point is completely greater than the endpoint of the new interval. And then this overlapping checking is a bit more interesting. As you can see, we're checking different conditions in here. So graphically, if the endpoint of the existing interval is stays in between the new interval and they are overlapping, or if the existing interval's starting point is within the new interval, in that case, they have some overlapping as well. And in these two cases, as we can see that either the new interval completely stays inside the existing interval, they are overlapping, or the existing interval stays inside the new interval, they are overlapping as well. So this for if statements is taking care of those four different scenarios. Otherwise, you just return a false, and the same as on the left and on the right. And then the merging function is pretty easy. So basically, we're taking the minimum of the starting point and the maximum of the ending point of the two intervals, and then return that, and become a merge of the list of between the two. So as I mentioned, the time complexity is a big O of n, and the space complexity is just occupied by this return list, which is similar to the space complexity, which is similar to the size, the sum of the size of the original intervals and the new interval. So the maximum will be the big O of n plus 1. 1 being the new interval, n being the number of intervals in the given intervals. So this is so much about my solution. I hope you like it. If you do, please hit the like button and subscribe to the channel, and I will see you in the next video. Thanks. See you next time.